Go ahead and get started. Welcome back. Some fun programming exercises today, I think, to work through together. A little bit of problem solving with regards to arrays. Where we left off on Wednesday was, I think, a critical point, right? So the idea and one of the value propositions of having arrays in the first place is because they just very naturally connect to our existing concept of using for loops to iterate through some particular task. And you'll see that code pattern just over and over again. We're going to have a problem for which part of the solution would be declaring a variable of an array type. And we are going to have one or multiple loops, and oftentimes it would be a for loop for this, one or multiple loops to either initialize the array or change some value in the array or use those values in an array to calculate something else. And it just, there's no coincidence there. It's not an accident that that's the case, that this exact kind of syntax of our for loop that usually typically starts at 0, has this iterator I, connects very closely to having an array of that same length. And then given an array, you access z of I, and then you do whatever you need to do for each step I. Just like with our other code that used for loops, that can lead to very nice, sort of efficient, small amount of lines of code, but debugging it still becomes a challenge, right? We still now have to kind of debug maybe just a few lines of code, but are executing possibly dozens, possibly millions of times, right? And that makes our life a little bit harder. So we're gonna have a few examples of messing around with building, debugging arrays using our for loops. And again, as with all of our problem solving this semester, the best approach is just to try to gain experience in working with that class of problems, and then to see what things work for you and make sense for you as you gain that experience. So here is today's, at least initial problem solving exercise, and it's written very intentionally, and it's kind of scoped sort of intentionally to eliminate a little bit of potential ambiguity in the problem. So our job is to write a program that reads in a set of midterm scores. Fortunately, it's not corresponding to this class. We don't have midterm scores. No more than 50, and reports back the class average on a scale from 0 to 100%. So you read in a certain number of midterm scores. Once you're done, you report back out the class scored this percent average on the midterm. So just to give an example, if the midterm was 60 points, and after entering those 4 scores, you can just do the math by hand, it should print out 75% because they averaged 45 out of 60 across those 4 scores. The other simplifying assumption, and there's a couple in this description, is that after entering -1 for a value, that will be our mechanism by which we know there's no additional scores to enter. Now, there's lots of ways we could describe that problem and could limit the problem, but that's just one mechanism, that we assume all these scores are going to be values greater than or equal to 0. That's usually a fair assumption. And so if there is a score entered in as -1, that is kind of our end delimiter saying, okay, there's no more scores. You can actually now move on to the average calculation here. So I just have Replit open. This is program lecture 502 midterm scores, and I really just copy pasted that same exact text here. So I don't want to do it for you. Let's all do it together. We'll start with what we always know, right? We're writing a C program, in this case just a single function main. So that syntax doesn't really have to change. You can always have that, and Replit will generate that for you anyway. So we have that already. We need variable to store the actual midterm scores. Now, technically, if one were to look at the scope of this problem, you could implement it without using an array. You could keep a running average of the running calculation of the average, and then once the -1 score was received, then you could just update and print out that average. For now, for the purposes of having this be a valid exercise in the context of arrays, let us assume that there's an array variable that is going to store those scores for those midterms. What do we want to call that array variable? Feel free to score? Well, it's multiple scores. We'll call it scores. And it's going to be an array. And that's our syntax where we use those brackets. Now, we do in this case, because we're not going to be able to initialize that array to anything, we do need to know how large that array is going to be statically. At least with the mechanisms for programming that we have right now with our arrays, we need to know how big it's going to be. How big should this array be? Absolutely. Now, here's where we talk about, how dynamic or flexible do you want your program to be? My argument that I made on Wednesday that I just want to kind of be consistent with today is it's probably better coding practice to have some sort of pound define or some sort of constant define where you just define that in your program where, hey, given this particular problem specification, there's 50 maximum students. And then since we know there's no more than 50, we would encode it like such, where it's int array called scores of size 50 of size max students. That change doesn't change any functionality in the program. It was of size 50 a minute ago, it's still of exactly size 50. What this gives you, I think, are two things, right? Instead of kind of hard coding that number 50 throughout the program, we have a program that's a little bit more flexible, that tomorrow we've decided, oh, actually, Iowa State's enrollment has grown, we actually want to have 500 maximum students. If we do that, then in theory, if we've written our program with that max student as kind of an assumed part of the constraint, in theory, we don't have to change anything else in the program, in theory at least. If we had instead just used 50 throughout, then we'd really have to kind of go back in and sort of inspect, not necessarily line by line, but we would have to inspect and kind of figure out, hey, where else did I kind of assume the number was always 50 in my program? And now I have to go back and double check what it would mean to change that to be 500. So I think for that reason, this is generally a good approach to take. There's another parameter given here that mentions, like, if the midterm was 60 points and we would need to know how many points the midterm was, that's not really given that we would want to ask for that. We could have that be an input that is provided by a user. Instead, for now, let's just assume, to simplify the rest of the program, that there's some maximum score associated with the midterm. That 60 out of 60 points is a perfect score on this particular program. So we know that we have to read in inputs, right? We have to read in scores from the user. If we wanted to read in just a single score, we know how to do that, right? We have our printf kind of scanf prompt combo, enter in the score. If it was just for a single one, enter in the score with our printf. Well, we kind of forgot to do like standard io.h. It was probably still going to work, but that's why it was kind of uncertain about that function call there. And then we would have to have some sort of scanf prompt. An integer should be sufficient for that. Let's call that current score, where somewhere we've defined a variable to kind of keep track of the current score that we've wanted to read in. So if it was just reading in our program just a single score, we know how to do that. We could also print out that score after the fact. Now we know that we're not necessarily just reading in a single score, right? We're reading in up to 50 or max student total scores. So what do we have to add before we jump into that printf scanf loop here? What should we add? For loop should be perfect for this. Let's define our int I. Again, you can define int I separately, or you can just, if we only are going to use it for the loop, just define it right then and there. Start it at 0 because we're going to be accessing an array. How many times should this loop iterate? Yeah, max students. Yep, absolutely. I++. Now there's a little bit of a chicken and egg in terms of coding this, but we'll get it working. And then, I don't know if you saw what I just did. You could auto-format it, but knowing that this is going to be inside a loop, you really want to make sure your indenting is pretty consistent. I just selected it all and hit tab, and that actually indented one too many lines. Or you just hit that auto-format button and things look a little bit better. You want it to be visually obvious to you and anyone looking at this program that this is happening inside that loop. That indenting isn't required, but it gives us a nice little hint. I would also argue, now that this prompt is going to be in a loop, it might be helpful to add a little bit of just kind of built-in debug information to that prompt. So instead of enter in the score for a singular score, let's enter in score I. Actually, let's make it I plus 1. So we're not saying enter in score 0, but we're saying, enter in score 1, score 2, score 3, score 4. That's different than writing I plus plus here, right? If we had written I plus plus here, it would have actually incremented the value of I and changed it. We don't want to do that. We just want to be able to say, hey, we're starting at 0 because that's how we start our for loops when we're accessing an array. That loop is still going to iterate 50 times, right? That was kind of one of the quiz questions, but that loop, 0, I less than 50, iterates 50 times, but perhaps for printing out which iteration we're on, we may want to sometimes print I plus 1, because we count with our fingers. We start with 1 here. So enter in score 1, then enter in score 2. We want to add that score that we have created to that array of scores. And there's a little bit more work I think we potentially have to do for that. But ignoring that extra work for that, how do we update that array scores with that current score? What would we have to do? I want to update scores with the score we just read in. It's a very common code pattern. Arguably, we could do it without a separate variable called current score, but we have it. There's no harm. Something like that. We do have to assign it. So we have current score. We need to put it in that array. We need to put it in the array. So the left-hand side of the equal operator or the assignment operator should be the array, right? So it would be scores of something. That's still a bug. We haven't put the thing in there yet. Is equal to current score. You see the syntax error there. Well, you probably can't see it. I can see it on my screen. It's unhappy with that because we have to subscript it. We're saying we're not assigning the entire array. We're assigning, in our case, like one element of that array at a time. So we always have to put an integer inside this array to specify which one we want to assign. We're on iteration I of the loop. So which element of scores should we be updating? Just I. I would also argue that because we're going to be calculating, we could have used I for this purpose. I don't like reusing I. I is iterating through the loop. Because we're also calculating an average, we're going to need to know the total number of scores that we've grabbed so far, or ultimately how many scores we've read in to do that average. Because we need that denominator to actually calculate the average here. The variable I is technically keeping track of that, but that's only for this loop. So every time we actually update a score, it may be useful to also update that count variable as well to say, hey, by the time we're done with this loop, we'll have an array of scores which is of size 50, and we'll have count number of valid things inside it. So count starts at 0. We read in one thing at location 0, and now count is going to have a value of 1. So it's not always going to be divided by 50 because we may not actually input 50 things in any given time. In fact, we probably have to check first whether it's valid, right? Whether this was a valid score or whether it was entering in -1 for a value, in which case there are no more scores to enter. Your challenge as the programmer, taking this sentence and translating this with what we have in code. Again, I'm never tricking you this semester. I'm never giving you an assumption that doesn't directly map to something we have been talking about. But it could have been 5 days ago. It could have been 5 weeks ago by the end of the semester. So if someone enters in -1 for a value, there are no more scores to enter. If I'd said if, maybe it would have been obvious. If the score was entered in -1 for a value, there are no more scores to enter. What kind of construct do we need to add here, let's say on line 25 first, that checks whether it was equal to -1? If, thank you. If what? The variable we read in, I like your thought process, we're reading in current score, right? Yeah, we could check if it's greater than, or if it's not greater than 0. Oh, I see what you're saying. let's check if it's actually just equal to -1. Your approach would also work, checking if it's not equal to -1. If, we should probably add a comment right here, right? Assumption, after entering -1, there are no more scores to enter. We didn't add a lot of comments here. That looks great. There you go. And then, for this whole loop is, read in the scores. We should be adding comments. Okay. If the score equals -1, there are no more scores to enter. What does that mean in terms of this program, with where we are in the program? If score equals -1, what should we do in our program next? Absolutely, that's the right keyword. That's literally what we have to do. If the score is entered in as -1, we need to get out of this loop, essentially, right? You could set I equal to max students or something, but we have that construct specifically for saying, get me out of this loop. There's other ways we could have done a while. There's other things we could have done. It's a for loop that by default is going to execute max students or 50 times until we get that -1. And when we get that -1, get out of here. We're done with this particular loop. That's a very valid use of the break keyword to get ourselves out of a loop, earlier than the maximum number of iterations. I would argue we've written enough code that we should probably test it at this point. So we have a for loop that reads in a certain number of values. I would create a for loop that prints out the values we read in. Just confirm that our printf scanf is doing what it needs to do. You entered in this many valid scores. What variable keeps track of how many valid scores were entered? Yep, you've entered in that many. Then I would make another for loop. Notice I'm reusing I, but that's okay. I is just this temporary thing that's just getting me through this loop. It's not I less than max students to print them out. It's I less than now count. And, I don't know, score %D is equal to that. I don't know. This is just kind of quick and dirty to confirm that we actually have the data we think we entered. You entered in, what was the example given up here? 4 valid scores. Score 1, 45, 47, 35, 53, -1, and you entered in 4 valid scores, and it just repeating the values back to us. It's always good to have that, right? That took just 30 seconds to add that little extra for loop to print out the values we believe that we read in. We technically don't want it anymore, because it's not part of the program spec. Comment it out with a multi-line comment. If you don't even want to see it, just minimize that little block with the arrow on the side in your editor there. No harm, right? We've debugged it at least for 4 scores. We didn't fully debug it. We probably should enter in 50 scores and things like that. But for at least the 4-score scenario, it actually worked for us. How do we calculate the average then? Not in terms of code, just mathematically. What do we have to do to calculate the average? Let's add them all up. Got a variable name for me for the sum of all the scores? Score total. Oops. Score total equals 0. Let's add a little comment here. Add up all the scores. What do we need here now? Somebody else. Good answer, by the way. But what do we need here now? We have this array of length 50, but for which there's only maybe count number of total valid entries inside it. The rest would all be zeros. I guess that wouldn't hurt to add a bunch of zeros, but still, sure. Yeah, I should probably keep this commented one visible because it's kind of the same loop, right? We got our nice sum variable, but hey, I like it. We'll just call it sum. We've just saved ourselves a bunch of keystrokes here. Sorry, your variable name got overwritten. We have a sum variable, sum versus score count, score total, sum. And now what do we have to do with sum inside the for loop? Yep. So, you may be looking at the code the way we've currently structured it and say, well, you now have 1, 2, 3, 4 loops. Isn't it possible to kind of combine those loops all into one and read it in and print it out and add it up as you go? Yeah, and that's usually a valid way to refactor a program. There isn't really a major performance consideration. Which version of the code would be more readable is kind of also debatable, whether it was one sort of big for loop that's doing everything versus several more svelte for loops that are kind of just responsible for one thing. So there isn't a dictum saying you should combine this or not, but we could have. We could have calculated the sum. We could have done it right here, right, if we had wanted to update the sum as soon as we had the value. But we also can just do it separately. We have a for loop, adds up all the scores, and now we have to calculate the average. How do we do that? We have a total sum. What would our average be? Yep, so we need another variable. What do you want to call it for our average? Very good, we're saving more keystrokes as we go. Now you notice here, we talk about where we define our variables and the scoping rules and things associated with them. That's also debatable. I think there's real values in having the variables defined close to where you're using them. We could have put all these variables at the very top of the function, but then, at least on this screen, I can't really see them anymore. I might have forgotten, was it called AVG or average or score average? There's no harm. I'm not going to be using average before line 48 here, defining it right there as you use it, and that would be sum divided by count. Doesn't seem quite right. It's close. What part of that are we missing then? We've added up all the total points and divided by the total number of students. So 45 plus 47 plus 35 plus 53 divided by 4 is what that would calculate. But what is this spec asking us to do? Something very slightly different. Got to get a percent value. Yep, how would we do that? Think about it for a moment. That's fine. So right now we're saying this would be average points. I guess would be a correct way to phrase that, right? As a fraction, right, of the total number of points obtained. But if we actually want to get the points obtained as a percentage, it wouldn't be sum divided by count. It would be sum divided by count times max score, right? Because that is 4 students, and ideally they could have gotten 60 points each, so 240 points. What amount of that score did you get out of that 60? And a couple other things, well, we should print it out, right? The average score across the students was the count average. This still isn't quite right, but let's do it again. Let's run it now. I wish I had those numbers handy. 45. There's a risk in testing in only one value, but it's the only one we could really easily confirm. Oh, -1 for our 5th score. The average score across 4 students was 0. What happened? Yep. Yeah, and that's just, you get that wrong, and then you remember, oh yeah, that's not good enough. So we need to use a float. That's starting point. That doesn't entirely fix it for us. We want to make sure we print a float then instead. We didn't specify significant digits, let's say 2.1f, 1 digit of values. Let's run it again. I already forgot, 35, 53, 0.0. So now it's a floating point 0. Wouldn't put it past Canvas to not have the same exact issue. This was also a week 1 bug. You could also temporarily make sum and count score. Yeah, and the term we use for that, that's correct. It would be to cast one of them as a float. So for the purposes of this line of code, basically, treat either sum or count as a floating point value. The rules in C are that if one of the values in an arithmetic expression is a float, they all get promoted to float. This number is still going to be a fraction, whereas if we want a percentage, then we can promote by having a floating point value that way, where we multiply it by 100.0 to give us a value that's not 0.75, but actually 75.0 in this case. There we go. When you get 0 for a result and you're doing something that involves division, just stop and say, okay. And a couple of you did catch that, which is great. The fix is something that may take you a little bit. The fix wasn't as simple as just making this a float. You need to make sure the actual arithmetic is being treated as a floating point value as well, or you're going to have truncation and other kind of bugs along the way. But when you see that the code looks fine, like the equation looks fine, the math looks okay, but I'm still getting zeros or just wrong results, that's a very common bug that you may have. We should probably check it with something else. I don't know. Let's say 60, 60, 60, 60, 60, which is what I expect for exams in this class. And then we get our 100% across 5 students. It's kind of annoying if you actually want to print the percent sign. I think it's \%. But that did not look right. Nope, it was not \%. Is it %%? Let me try that one. Yeah, there we go. Because percent is already kind of reserved for that format specifier, there has to be some other way to actually print out the percent symbol itself, and there you have it. Questions about this example? Yeah, sure. Like a initialized array. Okay, well, finish your question. I'll see if I understand you. So if you wanted it as an array. Right, is if we had something like this, right? Where it was like this. Yeah, that. Yeah, so let's be clear about what we did in this example, though, because this method that we show on line 18, just to show illustrative here, is also an array. It's just an array that's initialized at the time it's declared. Whereas this code for that, I called it scores2 to call it something different. This scores here is initialized at some point afterwards, but it is initialized. This is a for loop that goes upwards of 50 times. We're accessing scores of 0, of 1, of 2, of 3, of 4. That array is an array. They're equivalent to each other if we entered in those same 4 values. It's the same in C. It's the same. So if you were using Python and you were initializing a list versus a vector type, you may get some different trade-offs involved in that. In C, the way we've done this, scores and scores2, same exact usage scenario. They're no different than each other, because we are still required, no matter what, when we want to access it, we access it element by element. Similar to this question, let's say I'm going to print out the whole matrix. Yep. We need a loop for it in C. So we need that. We commented out, but it was here, right? A loop that prints out on an I by I basis each of the individual elements inside that array. So this means we can't do it without. Nope, unfortunately. Yeah. Because I think we already used the loop to make a matrix for these elements. Right. So I thought it's going to be like, you can do it. That would be nice. In a sense, there is no, there really isn't sort of a first-class citizen, this array type in C, unlike in other languages. It is just a collection of ints or floats or what have you. So it would be very nice if I could do something like this. All scores equals this, I don't know. And then like you could do just scores or something like that. Not in C. I mean, this isn't too bad. And you could write your own function eventually called, print scores. You just have to write it yourself, and then once you've written it once, you don't have to worry about it ever again. But this code where there's a for loop that goes element by element to print it out in a certain way, it's not hard. It's just a few lines and you'll get the muscle memory for it pretty quickly, but kind of unavoidable to do it at least once in C. Unlike other languages, the array is really just a way to collect elements of the same type together. Doesn't give you a lot of benefits otherwise. So if it really depends. If your first programming environment was in MATLAB, that kind of thing can be pretty frustrating, right? I mean, where arrays and multidimensional arrays are kind of baked in fundamental to the language and the environment itself. There's a true REPL where you can just inspect data and print out the values of data just by declaring and writing the variable name. You don't really get that in C, but you learn to deal with those kind of limitations as well. This topic is also important, but I think we'll have to be coming back to it as circumstances require us, which is multi-dimensional arrays in C. It is very important for engineering and scientific applications to be able to support multi-dimensional arrays. We stay one-dimensional a decent amount of the time, but again, for anything with image processing, you need two-dimensional arrays just to begin with. You can have two-dimensional arrays using this kind of syntax where the dimensionalities start on the left and then go from left to right. The way you'd want to phrase that or say that out loud, A2 of size 4 by 4. We could say 4 rows by 4 columns, and you can, that's correct. But rows and columns, that terminology only really works for 2 dimensions anyway. So 4 is the first dimension, 4 is the second dimension would be the other way to phrase it. We really have trouble visualizing things past 2 or maybe 3 dimensions, but there's really no limitation. There might be of like 256 or something, but in general, there's no practical limitation of the number of dimensions you can have for your array types in C. In my experience, anything beyond 3 dimensions is pretty rare, and that, given the nature of the data we tend to have to work with, but it's valid. So we could have in this circumstance a 4-dimensional array where there's 4 groupings of 3 groupings of 6 groupings of these arrays of size 2 here. Couple things that make it kind of manageable for us is you just multiply those dimensions together to figure out, how big is this total array? First one is of size 4. Second one is of size 4 by 4, so there's 16 elements in it. Even this one, 4 by 3 by 6 by 2, I don't know, 72, whatever that is, total number of elements in that particular array. And it does also turn out that anything you can choose to do in your program with a multi-dimensional array, there's also going to be an equivalent program one can write that uses just a single-dimensional array for the same. And sometimes this is more of a matter of personal preference, how highly dimensional you have your individual array variables be in your program. At the very least for now, we have to be aware that this is a valid thing to do in C, and you'll see lots of programs that use that. This is the initialization syntax. You use an additional stack of curly braces to indicate each individual dimension you are initializing. You may just forget, does it go row by row or column by column in C? And this is not the case in every programming language. It goes row by row, and that's how it gets laid out in memory as well. So if this was offset 0 in memory, this is 1, 2, 3. This next one would be at location 4 in memory, then 5, 6, 7, etc. So it's laid out in a row by row fashion. And always, when you're writing a program and let's say you're dealing with a multidimensional array and you're just not sure, where is element 2, 3? Just print it out. Just check. Just add a debug statement and just confirm that your data looks like you expect your data to look like. So you subscript when you want to then access the array elements from left to right. So A of, I use the word comma, but there's not actually a comma in this language, but A of 3, comma 2. First dimension is 3, second dimension value is 2, would be 15 in this example. Let's make sure we understand that. Why is it 15? We're indexing starting at 0 still in all of our dimensions. So when I say 3, comma 2, that is first dimension 0, 1, 2, 3, second dimension, and 0, 1, 2. That is why we get a value of 15. Again, normally it'll be I, J in your programs, right, as you're writing for loops and the like. And if you're just not sure, should it be IJ, should it be JI, should it be I plus 1, J minus 1, those will be a common type of bugs you will have in your programs anyway. I mean, it's not trivial. You'll have to work through it. Just print it out, test it out, confirm what's happening. Let's test our understanding. When I want to print out or access A of 1, comma 0, what value would that be? You got it. Does everyone else see that that is 5? 1, 2 would be what? 7. You got it. 3, 0. It's all good. 3, 0 would be what? 13. 0, 1, 2, 3. Again, you can like mentally add a +1 if you want to count internally in your head from 1. But in C, we index things from 0. The base address offset is 0 by default. So 3, comma 0 means 0, 1, 2, 3 in that first dimension. Starting up here, working our way down, and then no offset in that second dimension, 13. 0, 3 would then be what? 4. And 4, 1 would be not valid, right? Replit may give us a 0 back out because Replit seemed to be playing some tricks where it was 0 initializing all of our memory. How that works in practice is actually an implementation detail of how the C compiler works, how the underlying memory subsystem would work. The term you may want to look at is called row major order. And as I already just mentioned, it's not that uncommon to take what would otherwise be a two-dimensional object and instead treat it as a long one-dimensional array and vice versa. If you had some variable that kept track, or a pound defined that kept track of the number of columns, that would be 4 in this case, they are equivalent to each other. A of the yth row and the xth column would be equivalent to B, or just A as well, if it was the same starting location, of X plus Y times the number of columns, because every time we go from row to row to row, we're adding an offset equivalent to the size of our columns here. So you will eventually see that in some programs. That's true for two-dimensional, it's true for all these potential dimensional objects. When it gets ultimately compiled down to assembly code and it's running on the underlying processor, this does tend to happen. This is for you, the programmer. The underlying processor is just doing load and store commands that have just a single address as their input, and so it kind of linearizes memory. Because again, ultimately, that's our programmer's view of what's in memory. It's an address and a series of 1s and 0s at that particular address, and it's this big linear array of memory. This allows us to have a little bit of multidimensionality to our variables in our programs. At the end of the day, still just going in DRAM somewhere, starting at some base location. Yeah, sure. Well, you really can only visualize that for 2 dimensions, and then it kind of falls apart at that point. So, so no, I guess, unfortunately, right? And so it maybe I don't have the right verbiage to kind of explain that more appropriately to you as a class. But it's from left to right always in terms of what order we subscript, what order they are getting laid out. But once you get to 5 dimensions, it's not really up, down, or anything like that anymore. So for always left to right, right. In your own code, if you decided, well, again, these variable names are arbitrary as well, right? I mean, what is X and what is Y? We like to think of X as being our horizontal axis and Y as being our vertical axis. Doesn't have to be, right? That was Descartes' decision. We don't have to stick to that if we don't want to. Same with I and J, right? We don't have to use I and J. We could decide that we want to flip the order and then at the end of the day. So what is true is that the layout is a given. Where they're actually getting laid out is going to be effectively on what they call row by row sort of order. That is whatever that last dimension is, those are our rows. And that's how they're getting linearized in memory. And it's usually the approach we want to follow that we also want to access our memory on a row by row basis. There's a performance consideration for why that's the case. If you want to look up like what a CPU cache is, C-A-C-H-E, and why that's the case, the class that teaches that is CPRE 381. You're not required to take it, but it's a very good class. You have the option to take that at some point as double E's. It does turn out that there can be significant performance implication of accessing things row by row versus not row by row in our arrays. We can try, if time permits, to give it a try and see if we can see the performance details. The differences between accessing row by row versus column by column. The issue is that sometimes the compiler is too smart for us, and even if we do it wrong as programmers, the compiler may be smart enough to kind of reorder things for us so that we don't see the implications there. But at least in theory, there's a big performance implication in terms of what order we access memory. Otherwise, when you're working with your arrays, be they one-dimensional or two-dimensionals, you really just have to keep track of two things, right? What are my dimensions? Again, life is easy if it's 4 by 4 because you can't really get it wrong, you know? It's 4, so even if you do it in the wrong order, you're still accessing all 16 elements in the array eventually. But you have to keep track of what your dimensions are. You have to be aware of that as you're writing your program. You have to always remember kind of where your question was getting to earlier about printing the array or initializing the array. You have to always remember that the array is really nothing special in C. It doesn't get any like extra privileges because it's an array. And so you're always having to grab the individual elements back out of the array. And then remembering that you have for loops that generally are going to be tracking the dimensions you have of your array. You keep track of those three things, and one of those is really just a constant reminder in the back of your head. And your code doesn't look all that bad, and it tends to have kind of a natural flow to it. It's a lot more lines of code than what other languages would allow you to do for the same kind of operations. But it can be a very straightforward thing to kind of just pattern match as you look at these examples. So this is an example of a very common C design patterns where we need to copy one array to another array. In this case, it's copying a two-dimensional array A to another two-dimensional array called B. In other programming languages, you would just say B equals A. Can't do it in C. That's one of the things I want you to remember. The array is really nothing special, just in a name for a larger storage of variables of a given type here. There is a function that does this for you, and we'll look at the function very briefly today. But otherwise, you just have to remember, if I really want to copy A over to B, what I actually want to copy is every element of A into the corresponding equivalent location inside B. That works for one dimension, it works for two dimensions, it works for as many dimensions as you would possibly want in your example. So this code here, where we just have an arbitrary, just to have different values. Before we had max students or whatever it was called, this is kind of the same thing, except instead of just a single pound defined for the dimensionality, there's two of them because it's going to be two-dimensional arrays. 5 is the number of rows, 10 is the number of columns. We're then going to find two different variables that are both two-dimensional arrays of that size. Again, rows and columns, that only works really for 2 dimensions. But dimension 1, dimension 2. How many ints are being declared on line 9 then? It's one variable, but how many integers are being declared? 50, right? You got it. Because it's 5 rows and 10 columns each. So there's 50 integers and 50 integers for B. We need some way to initialize it. I don't want to type in values for 50 values. In this case, just a random value in the range -10 to 10. We've talked only a little bit about rand, and then we've been using it some amount in the lab. What is this code doing? Well, rand returns a random integer in the entire valid range of unsigned integers. That's 0 to whatever that 4 billion value is. That's oftentimes a little unwieldy to work with. let's get it to be a value between 0 and 20. That's what mod 21 would give us. And then let's subtract 10 from that value. That would give us effectively a random number in the range negative 10 to 10. Why negative 10 to 10? It doesn't matter. Just for some random value that we can actually look at here. We supposedly initialize things. We probably want to print out that array. Print it out to confirm that we actually have the value that we would want here. What kind of structure do we need to print out this two-dimensional array then? Yeah, and at this point, if you want to start like copy-pasting the header part of that for loop, that seems fair. Just make sure you close it back off so you don't forget about that part and that requirement there. Printing out multi-dimensional data, again, really only makes sense for up to 2 dimensions because we have a 2-dimensional screen and it's going to get unwieldy quickly, but we should be able to do it for this. We should be able to print out like a little header, like, print A of, and here's the dimensions of A, is equal to, this, where we print out num rows and num cols. And then we know inside here, we're going to be printing out a single value. That's going to be A of I of j, just like we're initializing A of I, j there. And then we probably want, well, we could try that. It's not going to look good because, we have this 2-dimensional thing and we're not really printing out the dimensions appropriately. Before each row, let's print out a little header. That should look okay. And then after each row, let's close that off. That's a little bit, that looks pretty good. I mean, with random values, part of the issue is can't really tell if it's correct or not when you're printing out the variables. It should, oh, that's not right. Let's just do 3D. I don't want zeros in front. All right, at least it's like, horizontally aligned and look a little bit better there. That's the trade-off of random values versus user-entered values. That looks close-ish to correct, but I don't actually know because I don't know what values got generated. That comma at the end is kind of annoying to me. How do we get rid of that comma at the end of each row? Like right here. How would you do it? I want to print out the same exact values. I don't want to print that last comma. Take it off. I can take it off of every element. I only want to take it off the last one. Don't print the comma. Yep, you could do an if statement. You could also, absolutely. You could just, hey, that inner loop, I actually don't want to print that last element in each row in the loop itself. And instead, I'm just going to print it here. Same concept, both would work. %3d with a closing thing there. With that comma is fine. And that would be A of I of what we would be printing. The very last entry in that column, what would we print? What would it be? Start at 0. That's the first one in the row. A of I is 0. What's the last one in the row? Yep. And we got rid of that comma. There's still technically a comma here. No, that's... All right, well, since we're here, let's do it right. Let's get rid of that comma too. And then at the very end of the loop, we've gotten through all the loops. And there should be a final closing bracket then as well as at the very end. So this is very important to fix. We print out the very last element without that extra. Oh, let's not overthink it. What did I do? Because it is the very last one, I less than, we'll go back and keep that comma because I don't want to fix it. That comma, that last one was intentional. Okay, fine. We now want to actually copy the results over from A into B. We're out of time. We'll copy A to B. That will be done. Copy A to B. What would that require? What construct do we want to add? Do it again. Yep. And let's copy this whole loop, even though it's not quite entirely what we want. Again, that design pattern is just going to be so common. We can't copy A to B as a whole, but we can do it element by element. By the way, not a lot of typing here, right? A lot of copy paste. Then we want to confirm that we've actually copied it properly. Let's print out B. And my recommendation, again, you still have to be careful when you do this, right? Every time you copy paste a block of code, you've saved yourself some typing, which could save mistakes. And now you have to go back and very carefully check, hey, I've copied this block. Did I update it accordingly? You tell me and then you can leave. What things do we have to change now that I've copied that printout block? On line 38, what do we have to change? Yeah, probably call that B. What else do we have to change? Basically, everywhere we see A, we want to change it to B. Doing it manually is probably still the right approach because then you're manually inspecting like what you're doing here. That should give us an array A. Let's put a little space between them. And the value of B should be identical. Let's leave things here for today. Remind me on Monday about switching the order of our I and J loops and what that might mean for performance. We'll try to test it out and see what happens. Leave things here for today. See everyone on Monday.